All right. So a lot of geometry is about triangles and how those side lengths fit together and those sorts of things. So it says describe the possible lengths for the third side of the triangle given the two sides 10 and 5. So a part of triangles, a basic property of triangles, is that um, the two side lengths have to always add up to be more than the third side. So if we have two side lengths of 10 and 5, um, when we add those together, we have to, when we add that those two and then whatever the third side is, they have to be more than the um, the other side. So, as an example here, uh, we could have a side of 6 because 6 plus 5 would be 11, and 5 plus 10 would be 15, which is more than 6. And so then we're good. We could go as large as, if we look at these options here, so it has to be bigger than 5 because in order to add the two sides together, um, it has to be bigger than 10. So this would get us the lower bound. And then on the upper end of it, if we add these two together, 10 and 5, that would be 15. Well, the other side would need to be less than that. So that's where we get our top bound there. That's something that you'll see that in geometry as you spend some time with that. So don't get too worried. That's just a little introduction there. Does anybody have any questions on that one? Okay. I like the heads shaking. I can see those. Thank you. All right, then the next one, it says, how do these triangles appear to be similar? So what we notice is, and we can only make uh, determinations in terms of what we're given. We can't assume anything about uh, geometric figures. So if it's not specifically marked or listed, then we can't say anything. So if we look at these, the similarity, and you see this like AA, SAS, SSS. A stands for angle and S stands for side. So these are three of the ways that we can tell that something is that triangles are similar. Angle is one, side side is one, and then a side is one. So as we look at this, well, to be similar, then we would have to have the um, side. If we're going to do this, it would have to be side. We've got these two sides that go together. We've got the 48 and the 16 sides that go together, but we don't have any other markings on those triangles. So there's nothing there to tell us that they would be. Okay. So in order for them to be similar, we need more information. So we can't say that they're similar at this point. Okay. Again, you'll get there, but know that that's something that you'll definitely see in geometry. Any questions on that one? Okay. All right. Thank you. Then let's take a look at the next one here. All right. It says, what is the correct order of the lengths of the streets from longest to shortest? And so if we look, it says Pine Street, Rector Street, and Taylor Street intersect to form a triangular shaped park as shown. Uh, so we know that that one angle is 64 degrees, that angle is 54 degrees. And what do we know about the angles in a triangle? Well, they add up to 180, right? So I have 54 and 64 used, and I know that there's going to be one other angle, and we know that that total is 180 degrees, right? So if we figure out what that missing x is, so basically you can subtract from 180, right? And so I gotta go this way, grab the calculator here. And so we have 54 plus 64, which is 118. And then I'm going to do a little trick here. I need 180 minus 118. If I make that negative and then add 180, I don't have to retype it. So we can do that right there. So 62. So that means that this top one, let's go back to our drawing here. The top, or I would call, I guess, the bottom one, this angle right here is 62 degrees. So that being the case, the longest sides, the bigger the angle, the longer the side's going to be. So in terms of the longest side, it's going to be the one that's opposite the largest angle. So if we look, 64 is our largest angle. So this is going to be the longest side right here, which is Rector Street, which is, we look at our options and we're down to B and C at this point. Then our next longest side, well, the next largest angle is 62. That's across from Pine Street right here. So Pine Street's going to be next. So at this point, we're down to option C. So it has to be option C. Okay. So taking our knowledge about triangles and applying it there. Does anybody have any questions on that one? Okay. All right. Next up. And I won't go crazy detailed on every one of these, but we'll get the big idea. Okay, ooh, here's another fun one. It says use the information in the diagram to determine the height of the tree. All right, so if we look, there's some markings here that are going to be really important to us, and we can use those to set up some similar triangles. So if I look, if I look here, notice that we've got these little marks right here. And remember, those marks mean that those two things are the same. So what that's telling us is that not only is this length 144, but so is this length right here. So the total for that side would be 144 plus 144, which would be 288. And then a similar thing on the bottom here, we have these two, so there's two marks. So that means those two sections are the same. That means this is 120. That total length then must be 240, okay? And we also know this right here is 160. This is the one that we're interested in right here to figure out that tree. So we can use a proportion. So we can set up a proportion, and remember the key for setting up a proportion is that we are consistent. So I'm gonna put all the stuff, we've got two triangles. We've got this one right here, and then we've got this one right here, okay? So I'm going to set up a proportion, and I'm gonna use the small triangle, and I'm gonna put the height, which is what I'm interested in, right there. I'm gonna call it X. I'm going to put that on the top, okay? So this is my small triangle, and then this is the large triangle, okay? So small triangle stuff, large triangle stuff. And then on the top, I'm going to put the height of the triangle, of each of those triangles. Oh, sometimes my little writing tablet doesn't work quite right. So the height, okay, and then I have a choice to make. I could do the diagonal right here, or I could do the bottom part here. I'm going to do the base because it's smaller. You can pick, it doesn't matter. Okay, so we're going to put the height over the base. So this is the small triangle. We've got the height. I need the base of the small triangle, which is 120. So that's going to go right here. Okay, then for the large triangle, I need the height. I have it. It's right here, 160. So that's going to go up there. And then the base of the large triangle, remember we had to add those two together, that's 240. So like that. Okay. Then There's only one thing we don't know, the x. And that's an important piece of this. We have to make sure that we include that x in there, because if we put the diagonals, then we would know everything, and that wouldn't help us. Oh, goodness. Now, we can do our cross products to solve that. So we have x times 240. So 240x equals, and then we've got 120 times 160. And let me grab my calculator here. I'm going to do it on my phone because I can't use the screen right now. So 120 plus 160 are times, holy cow. Okay, 19,200. And then divide by 240. You could also have canceled out some of those zeros to make life a little easier. And then we end up with x equals, so 19,200 divided by 240 will be divided by 240 should be 80. And sure enough, it is. So we end up with x equals 80 for our height. Okay? What questions do we have on that one? Does that make some sense? So it's identifying what we're given by understanding the diagram. Picture's worth 1,000 words, and then we can set up our proportion and go from there to solve. So, all right, awesome. Let me clear out this stuff, and we'll keep on keeping on here. All right, the next one. Okay, so this one is kind of similar. So it says to measure the distance across a pond, a surveyor locates points A, B, C, D, and E as shown. What is AB to the nearest meter? Okay, so we have two similar triangles again, and we know that these triangles are similar because one's inside of the other, and these two are parallel. I know it doesn't say that, but that has to be the case. So we can set up a proportion. We want to know the bottom part right there. So from A to B, that's the distance that we're interested in. And so I'm gonna use these two together because those go together. So my basic proportion is gonna be, I'm gonna put the, let's do the small triangle here again, and the large triangle stuff here, and then we'll call these two, we'll call that the base, and then so those will go on the top, and then on the, we know this whole distance right here, so we'll call that the right side, so RS for right side. Okay, and I just put these things around it so that I remember what's supposed to go where. It helps me to keep things organized, and I would encourage you to do that as you set up your proportions. Okay, so right here, the small triangle, I need the base on the top. So what's the base of the small triangle? 5, right there. And then I need the right side, which is this part right there. So that's 4. And then we go to the large triangle. I want the base, that's the X, that's the thing I'm looking for. And then the right side, well, it's 4 plus 8, so that's going to be 12 right there. Okay, so then we use our cross products again. And so 5 times 12 will be 60 equals 4, remember that's a 4, times X. So 4X divide by 4, divide by 4, and we end up with X equals 15, which will be right there. Okay, so again, using those similar triangles and using proportions. How are we feeling about that one? Good? All right, I see Oscar throws up his arm. All right, awesome. Okay, let's keep on keeping on here. All right, next one. It says, how do these triangles appear to be similar? All right, so it says, hint, look for non-labeled parts. Well, we have this side and this side, and notice that they're both the same. So the 16 and the 16. So in order for the triangles to be similar, these two sides would have to be the same as well, and they're not. So it's not similar. This would have to be either 40 or this would have to be 39 in order for them to be similar. And then they share this angle right here. Those are vertical angles. It's not really a shared angle. It's vertical angles. And those are equal. So we would have side, angle, side, but they're not in proportion to each other. So they are not similar. Okay. Anything on that one? All righty. Let's keep on keeping on here. Sliding up again. Okay, how do these appear to be similar? All right, so for this one, we have the, let's see, how do these triangles appear to be similar? We have the base being 9, and this, or I would call it the base because you could flip it over. This one's a little bit tricky because what they did is notice that we've got the angle here. So if we took that angle C and matched it up, it would go right here, and then the line that's this direction is 30, but on this one it's 9. So 30 and 9 would be the proportion. Then this one is 10, the one that's going up, and this one is 27. So the problem is that these two are flip-flopped. So this one would have to be 10, this would have to be 9 in order for them to be similar, in which case it would be, a lot of you are on the right track there, side, angle, side, but they tricked us because they put what would be the bottom, they flip-flop those two. Okay? Any questions on that one? All right. Okay, how do these triangles appear to be similar? We catch another one where they're not similar. The problem is, well, we've got the two right in the middle here. These two would be the same. And I got to use 4 marks here because they've got 1, 2, and 3. So these two would be the same. So that's one angle, but then this angle is different from that one. So those, it doesn't work. And then we don't know anything about this angle, and that one there is another different measurement. So in order to tell that they're similar, we would have to know this one right here. And if this one was the same as this one, then we could do angle, angle, but we don't know that. So again, they're not similar. Lots of not similar stuff in these. Okay, let's keep on. More not similar stuff. Let's see. Do the following side lengths form a triangle? 3, 10, and 7. Remember, in order for sides to form a triangle, any two of them added together have to be larger than the third side. And the reason for that is if we had, so let's say this one, oops, turn on my drawing here. If we have this side, which is 10, and then we've got a part that's 3, so part that's 3, and then we've got a part that's 7, and I'm just laying them out here. Oops. Wow, I don't know how I did that. We've got a part that's 7. Notice that in order to make all of these fit together, like if we drop the 3 and the 7 down, they would match up with the 10, but that's not a triangle. Those two together are the same length as the 10. So they would just be sitting on top of each other, which doesn't make a triangle. Okay? All right. And 15 there is similar. Another one where we're looking at those types of angles and so on. So let me stop sharing for a second here. and we'll go back to where I can see everybody. Uh, did anyone have any questions on any of that stuff? How are we feeling about those things? First of all, how many of you have had geometry class before? How many of you have already done geometry? Okay. All right. So hopefully, did it feel like a little bit of review when we started talking about some of that stuff? Okay. And if you haven't had geometry yet, there's a little preview of those things. You spend a lot of time looking at angles and triangles and all those sorts of things. So triangles are really cool because there's so many ways we can use them to do measurements. Especially that's one thing that really interested me when I was in high school is the relationships of the sides and the angles and triangles and how we could measure things that would be impossible to measure directly, like that one problem where it was measuring across water. Obviously, you couldn't use a tape measure to go across the lake or something like that, but using triangles, we can get those measurements, which is kind of cool. Now, or like think of the measurements of the size of the Earth, for example, or the solar system, the distance between uh, us and other planets and things like that. That's all that basic geometry using those triangles and stuff, which to me is kind of cool. So, um, anybody have any questions on any of that stuff? All right. We'll cycle around and see some of those things again, but hopefully it was helpful. Now we're going to switch gears and do that little competition of the addition of integers, and we'll do similar to what we did on Monday. I'll give you the link. I'm going to throw the link into our chat, so you can go ahead and click on that and use that. Okay, so there's the link. You can go ahead and click on it. You can do it more than once if you like, if you think you can do better. And I set it up so that you could potentially go quicker. I turned off the automatic, the feedback with the little check marks and stuff. So you can still see if you got it right or wrong in the scores up on the top right there. Okay, so give that a try. Once you have a score that you want to report and say, oh, here's my best for today, you can either put it privately into the chat, or if you just want to give it to everyone as a little competition between each other, that's perfectly fine too. So I look forward to seeing those results. Have at it. Go get it. Not too shabby on those results. Nicely done. Uh, that again is another skill that to me, the better we are with that mental math and can just look at that stuff and quickly do those types of problems, the easier things are going to be as we push to higher levels. So awesome job setting the baseline, and we'll work to get better. So um, just a couple friendly reminders. Remember, you had the video to watch in school or in Schoology, in Google Classroom for this week under week 3. A number of people have done that already, which is awesome. Thank you. And then at the end of the week, or by the end of the week, give me your progress on Mathagon and Khan Academy. You're just reporting me the score on Khan Academy, and on Mathagon fill out the 3-2-1 telling me what you learned about and questions that you have about any of those things. Does anybody have any questions on anything? All right, awesome. If you do have individual questions, please feel free to stick around and we can talk about those. Don't be afraid to send me an email, and keep working hard. I look forward to those um, assignments rolling in Google Classroom, and we'll keep getting better. All right, so we'll call it a day. If you have a question, again, stick around. Otherwise, we'll see you next Monday. Have a good one.